All right, let's talk about the square here today. We don't do kites anymore, just squares. You'll notice I only have 2 properties there listed. Everyone have the sheet of properties on your desk right now? You probably have 16 listed there. You know what you're looking at right now? All the properties of a square, that entire piece of paper. Because if you remember, I don't want to bring it up, but if you remember the tree, we had rectangle on one side, rhombus on the other, then we had 2 arrows connected it to the what? The square. The square has all rectangle properties and all rhombus properties. It's got everything. That's why we refer to it as the golden child. Well, that's contained in here, right? It's already contained in there. So everything on your piece of paper right now, a square has. That's a lot to deal with. Right? That is a lot to deal with. So up here, can you label this A, B, C, D for me? I want to put markings on it that would make it a square. First thing, it's got to be a rectangle or a rhombus first. Okay, so let's make this into a rhombus right now. Let's go all 4 sides congruent. We know that automatically makes it a rhombus. So what do you think would transform it into a square now? Any of the special rectangle properties we talked yesterday or the day before. All right, so what would make Gage? What's one thing that could turn that rhombus into a square?
Right angles.
How many? Do I need all 4? Watch, hey. Square. We don't need all 4 right angles, right? Or what else could I have? If I don't have a right angle, maybe what's another special property of a rectangle? Congruent diagonals. Maybe I have this with congruent diagonals instead. All right, everybody good? Draw yourself another square right next to it. So that's how I transform a rhombus into a square. Let's talk about how I transform a rectangle into a square. Let's call this EFGH. What would make this into an automatic rectangle? Just not one, though. Remember, this is just a quadrilateral right now. 4-sided figure. How do I transform into a rectangle? Show it's got automatic rect. Just like all 4 sides congruent makes it an automatic rhombus, all 4 right angles make it an automatic rectangle. All right, what would I need to make it into a square now? Think about the rhombus now, right? I have a rectangle. What else would I need to show this into a square that a rhombus has specifically? What's up, Bennett?
2 congruent sides that are next to each other.
Okay, yeah. Do I need all 4? No. Here's good enough for me. This would make it into a square. Or what's so special about the diagonals? Okay, I could show perpendicular diagonals. That would make it into a square as well. So is everyone seeing how to make a square? You got to start with a rectangle or rhombus and show it's got a property from the other one. All right, big time there. Questions? All right, so why do we have dry erase marker, dry erase boards, and little pieces of paper here? We're going to see what your group's made of today. All right, who's the best group in the nation in period 4 here? I am just going to leave number 1 to you guys and see what you got. You know a square has so many properties. Let's see what you got here with number 1. And leave your answer in radical form, please. Leave your answer in radical form. When you are confident, write down your answer, and then we're going to all hold it up at once and see what we got. See what we got here.
Yeah.
So talk it over with your group. Write it in your notes. I just need a final answer on the whiteboard. I don't need to see work. Leave your answer in simplest radical form. Leave your answer in simplest radical form. I don't want to tell you how to do this because there's multiple ways of doing this. You have all properties of a square.
The diagonals are 16, and they bisect each other, so it makes a triangle that's 8, and then you
Guys better confer with your group. We're going to raise all these boards up at the same time. Yeah, talk to each other.
But yeah, that is the length of one side.
the diagonals bisect each other, so they form a triangle.
Because the sides are.
Oh, yeah, okay. 7 plus 2, 2 is 16 squares.
Woo.
16 squares.
Talk to each other here.
Wait, so maybe I was wrong. Wait, so yeah, we did the same thing. Something.
Flip over your board so nobody else can look. You, right? If you and your group agree, then you're confident. Flip it over.
I got that. Yeah, you got it. I know
Little class bragging rights coming up here. This won't be the only time we're going to hold up answers. Finishing up.
I don't
All right, looks like everyone's ready. We're ready to do this. All right, hold them up. Whoa, we got some 32 radical 2s and we got a little 8 radical 2 over there. I could tell that group in the middle. Read the problem again. I'm not asking for the side of the square. What am I asking for? Perimeter, right? You guys gave me the side of the square. Need the perimeter, right? Need the perimeter. So take your 8 radical 2 and multiply it by 4, and you'll get your 32 radical 2. Good job. Do we need anybody questions going over that one? Okay, take your paper towel, clean it off, and just put it in the middle because we're not using it for the next problem. We will use it for the at the end of class, but not right now. Okay, so just wipe it off, put your marker on top, no distractions here. Go ahead and graph the next one for me. Go ahead and graph the next one. Little coordinate proof here with the square. Let's go. Put the marker down and start graphing number 2, please. Good job, groups. Good job. You guys good over here? You just had to find the perimeter. Okay. It's all right. Label those vertices. Okay, let's discuss here before we go. Let's discuss we need to prove it's a rhombus. We'll worry about the and part when we're done proving it a rhombus. Yesterday we said, oh, we are lucky if they ask us to prove a rhombus because it should be pretty easy. All we need to do is find all four sides are congruent. What formulas do I need? Distance. I know we groan, but good news here. You only have to do distance twice. What can you do with AT and MH? I don't need distance formula there. What can I just do? Yeah, count. How about that? All right, we could just count how long AT and MH are and then do distance on AM and TH. So we actually don't need four distance formula here. For step one, we can just say AT, count it up. 1, 2, 3, 4, 5. And MH, just count it to make sure. 1, 2, 3, 4, 5 again. Yep. So we know AM and TH should come out to be 5 when we do the distances, but I need to see that work. I need to see the work. And we're all getting 5 out. TH and AM, also 5 using the distance formula. Bless you. Hopefully you're picking up the style of how to do these coordinate proofs. Step 2 is always, what did we learn? What did we just learn? AT congruent to MH, congruent to TH, congruent to AM because distances are equal. And now we finish this off. Not done yet, but the first part anyway. We could say MATH is a rhombus. What's everyone throwing up for their because?
All sides
are.
Show me what, look above. All sides congruent. And the second part. Now show me it's not a square. Well, let's talk here because there's different versions we can do here. How do I show it's not a square? And I don't want you to do more work than you need to. How do I show this is not a square? One way, Gage.
Can you prove that there's no right angles?
Just one. I don't need to go all the way around and show once there's no one angle's not a right angle, it's not a square. What could I do with the diagonals? Show they are not congruent because that would be a rectangle, right? A rectangle property. So yep, show the diagonals are not congruent. So there are two methods right there. What do we want to do? Diagonals or no right angle? No right angle it is. What formula am I going to need for that? Slope, all right. Which one do we want to lock in on? Which angle do we want to show is not a right angle? M it is. All right, we're going to show M's not a right angle. So first, slope of MH. That should go a quick one in here. MH, 0. It's horizontal. Slope of MA. Up and over, let's see, 1, 2, 3, 4. 1, 2, 3, negative 4/3. How'd I do? Yeah. Negative 4/3. I know this sounds weird, but what did we just learn there? We learned that MH and MA are not. Oh, you're going to like this. Ready? Take that perpendicular sign. Yeah, get a nice little slash through that. Yeah. What, Teddy?
Why did it go 3 to 5?
I have no idea. That's a great question. I have no idea. Probably because I'm thinking about what I'm going to have you guys do next, and I'm all jacked up about it. Because there's going to be some serious competition going on. Why are they not perpendicular? Slopes are not negative reciprocals. I like it, guys. I like it. You're picking this up well. And this could have been any of two sides, any two consecutive sides. All right, what do you want to tell me now? If they're not perpendicular, that means M is not a right angle. Yeah, is it M we're doing, right? Yep. Angle M is not a right angle. Because? Yeah, the lines are not perpendicular. It's kind of like our statement's reasons, huh? And going back to Gage's point, you don't have to do this 3 other times, right? A square has all right angles. One of them's not. Guess what? Math's not a square. Why isn't it a square? Well, be careful there. I don't want to say because it doesn't have a right angle, because it doesn't have 4 right angles, correct? All right. Saying it doesn't have a right angle, math is not a square because it does not have 4 right angles. Okay, any questions here? Now we're gonna now it's gonna get real. Now it's gonna get real. All right, as you turn it over, we have, what do I have? 6 multiple choice questions there for you. We're gonna do this one at a time. You guys are gonna discuss it with your group. Write your choice down, flip over your board, and then the big reveal here, the big reveal. All right, so take a look at number 3. Discuss it within your groups. Come to a consensus, write it on the board, and flip it over. Here we go. Number 3 first. Properties of a square for cash.
Oh, yeah.
I have 3 because HC is perpendicular, so it's FHC.
But right, but SHC is not well, look at the first one.
I said SHC.
Right, that's right.
Absolutely not. Must be true. Must be true.
So the answer is number 3.
Oh, look at number 1. Because in a right.
Number 2.
Yeah, that's funny. Which 2?
Yeah.
Nope, just number 3. Write down your answer. Turn over your board when you're good. I like. I like some groups throwing out some different answers there just to get other people off track. I like it. I like it. Little gamesmanship. Gamesmanship.
We understand.
Oh my God, guys, write down.
All groups ready.
Number 2.
All right, let's see it. What do we got?
Just kidding. Just pretend.
Good. Choice 3. Look, diagonals are perpendicular. All angles are right angles, correct. You guys that were harping on number 1 here, these are equal. Diagonals bisect the angles, so these will be equal, right? They're equal. All right, here we go. Hey, here we go now. Now I'm really testing your group's ability if you know when it's a square or not. So number 4, what is not enough to prove the parallelogram a square? So it's already a parallelogram. So that means you need rectangle and rhombus properties both. So if you need to draw out the diagram to see if it's a square or not, which one is not good enough to say it's a square? It's going to start getting a little tough here now. And we're looking for which one is not sufficient.
Yeah.
And just to give you a little help, you got to read through and say, all right, this is a rhombus now. Is it staying a rhombus by the other property? Or is it's a rectangle now? Is it staying a rectangle based on the second property I give you? And remember, you got the properties right in front of you.
I just can't be one of them because the diagonals are about to run circles. I'm just trying to figure that out. But if they're perpendicular, then that's what it's 3. Yeah. Because the diagonals are
It's 2. It's 1.
Yeah, but it's one pair of adjacent sides. That's a rhombus. And so I get perpendicular diagonals. Oh. So I don't think that's it. Because I think both are
Five is three.
but that would prove wrong. But that would be right. And then the second one proves. So it's not.
Yes, it is right now.
Is it?
Oh, it's not.
We're almost.
Not yet, but.
It is too.
All right, look, we're good here? Nope. Still going back there, deciding. All right, we all set? Group back there, fellas, you good? Okay, group's ready? Okay, let's do a big reveal. Let's hold them up. We got 3. And then we got a 4 up here. We got a 4. Ooh.
It should be like eliminated. So much. I think it should be eliminated. Like survival.
Okay, ready? Go. Let's figure it. Diagonals are perpendicular. That makes it a rhombus right now. Good? That makes it a rhombus. So right now that's a rhombus. And one pair of adjacent sides are perpendicular, which means I get a right angle. So a rhombus with a right angle, square. Right? Because the rhombus, and then I'm giving you a rectangle property now. So that makes it into a square. We're looking for which one does not. 3 is the answer because diagonals are perpendicular. That's a rhombus. One pair of adjacent sides are congruent. That's still a rhombus property. Okay, so number 3 is not changing it from being a rhombus. We good? Okay, number 5. Here we go. Number 5. Make it into a rectangle now.
No, I thought that was a.
No.
B number 3.
All right, all groups ready? No? All right, let me know, fellas.
No, it literally is for that. I was trying to.
It's not three.
Actually, look, it is. What?
No, it's not.
Yes, it is. Yes, it is.
No, I can't.
We good here? Okay, let's go. Hold them up. What do we got? Let's take a look around. Correct. It is 3 because that gives you diagonals congruent. That is a rectangle property. Good. I'll just give you the answers for 6, 7, and 8 here because we're going to run out of time here in 2 minutes. Number 6, which one does not? That should be choice 1. Because that'll give you a rectangle. Number 7 should be choice 2, 40. That's a Pythagorean theorem question. And then can we all answer 8 together here? Which quadrilateral has diagonals that are always perpendicular bisectors? Look, perpendicular bisectors,
Oh, square.
right? That would be a square. Rhombus is not a choice, but correct. Rhombus is correct, but not a choice. So, yep. All right, you got a couple pages there, and we got our spelling bee tomorrow.